Hello and welcome back to the Maths Behind Economics. In this video, which is the 6th in the exponent series, we're going to discuss what happens when we raise a base power to an exponent and then we raise it again to another different exponent. So I'm going to show you how the rule works, then we discuss why the rule works and show the generic case as well, so basically proving the rule, and then I'm going to show you some practical examples. Right? Let's get started. So what is the rule? Well, a number to a power, and I'm raising that to another power, it's going to be the base. I'm keeping the base and I'm multiplying these two powers together. Right, so why? Why does that work? Why is that the case? So again, let's look at a specific example and try to work through the logic with that example. So what happened if I had 5 cubed and I wanted to square it? Well, squaring anything means multiplying it by itself, but in this specific case, we don't have 5, but we have got 5 cubed that I have to multiply together by itself twice. So again, what we did here, we use the definition of the exponent. I can apply the definition again because I remember that 5 cubed can be broken out to 5 times 5 times 5. And I can do that for both cases, both appearances of 5 cubed. Well, but what does it mean? Altogether, what we have here is 6 lots of 5. And again, remember that 6 is 2 lots of 3s. So 5 cubed squared at the end is 5 to the 6 because I have got 2 lots of cubes. Okay, so let's look at the generic example. So I have got a to the n and I'm raising that to the mth power. Well, again, applying the definition, what I have got here is a to the n times a to the n times a to the n. So here I've got m times. I've got m lots of a to the n's. Now, what else can I do? Well, remember that every one of these a to the n's are just a times a times a n times. So again, I'm using the definition of what a to the n now means. Well, I've got a few more of those. And I'm afraid that's going to be a bit of a long writing. And again, I have to keep repeating this pattern. Blah, blah, blah. And the last one is again going to be a times a times a, again, altogether n times. Now, how many of these I have? I have got altogether m times of them. So again, I've got m lots of n times multiplying a by itself. That's basically a to the n by m. Okay, let's look at a couple of examples. Right, make a bit more space. And I'm just going to write the rule up here again because it took a bit more space to write it out than I anticipated. So just have the rule up in here. So what's going on here? So I've got 4 cubed raised to the 5th power. So basically means I have got 5 lots of 4 to the cubes. So altogether, I'm going to have 4 to the 3 times 5, which is basically 4 to the 15. Next one, I'm going to have minus 5 to the 5th raised 2nd power, basically squared. So what happens in here? I have got the base minus 5 and I'm raising that to the 5th power, and after that I'm squaring it. So altogether it's going to be raised to the 10th power, that's the multiple of 5 and 2. I've got x cubed and I have to cube that again. Just because the base is now a letter, that doesn't mean any difference to the rule itself. I'm raising a power to a power. That's going to give me the multiple of those powers, and 3 times 3 is 9. I've got y to the 4 and I raise that to the nth power. Well, the base is not going to change, but what's going to happen now, I have to multiply 4 and n together, and that's going to give me 4n. So this is y to the 4n. And what I've got here is b to the minus c, and the whole thing squared. So again, the base does not change, and now the power will be multiplied together. So minus c times 2, that's going to give me minus 2c. And if you want to be funky, what you can do is remember that negative powers is 1 over, and you can write it b to the 2c. Now, this step is not always necessary. It will really depend on the type of questions you are asked. Sometimes it's perfectly valid to leave your answer as a negative power. Sometimes it makes more sense to write it over 1. Whether to leave your answer as a negative power or whether to take this extra step of writing it 1 over will depend on the specific question you're working on. Well, I hope you understand now why this rule works. I hope you have a bit more confidence by seeing a few examples. Thank you for watching and see you in the next one. Bye.